As we've already established, when you have two like charges that are brought near each other, you have a repulsive force. When you have two opposite charges that are brought near each other, you have an attractive force. What we have not talked about yet is the amount of force that you have between the two charges. That's where Coulombs Law comes in. Coulombs Law describes the relationship that you have and the amount of force you have between two charges, whether they're both the same charge or whether they're both opposite charges. Now, Coulombs Law is just F equals K Q1 Q2 over R squared. Now, in this case, K is a constant. And that constant equals 9 times 10 to the 9th. That's newtons meters squared divided by coulombs squared. Now, coulomb is actually the unit, is the SI unit of charge. So we're looking at Q1 and Q2. These are both going to be the charges of our two different particles. Q1 and Q2, that's a charge. That's a charge. We're going to say this is a charge of object 1. This is the charge of object 2. And that's in coulombs. That's capital C. Capital C is the coulombs. That's just the amount of charge that each charge is going to have. R then is the distance between the charges. Now, when you're using Coulombs Law, it should look very, very, very familiar to you because it is similar to Newton's law of universal gravitation. Because if you're talking about very, very, very microscopic particles like electrons or protons or even just molecules themselves and the number of electrons and protons that you have in those different molecules, there's a similar attraction that you have between the molecules that you'd have between planetary bodies. The only difference that we have, there's two main differences. The one is that the constant is a little bit different from Coulomb's law than it is for Newton's law of universal gravitation. The second thing is that with Coulomb's law, two charges, it's not always an attractive force. When you have two planetary bodies, for example, the Earth and the Moon, there's always that gravitational attractive force between the two of them. But with Coulomb's law, with the different particles, it could be a force of attraction, it could be a force of repulsion. It depends on the type of charges. Now, when I'm using Coulomb's law, I always keep Q1 and Q2 positive. I don't worry about whether the charge is positive or negative. I keep both of those positive, and then I have to think about what the force is really going to be. What direction is it going to be based off of the fact, are they both positive, are they both negative? If they're both positive, if they're both negative, then it's going to be a repulsive force. If one's positive and one's negative, then it's going to be an attractive force. So you kind of have to think about that as well when you're dealing with Coulomb's law. But this is really the basics of the law. We're going to do a couple of examples in the following videos, which will show you what you can use Coulomb's law to determine.